I'm not exactly sure why it cut me off, but I'm pretty sure that's a sign I'm talking too much. So we'll just do two more examples and be done with it. I'm not entirely sure where it cut off. So just know that if you have an exponent, you can bring it down. So the 2 came in front, the 2 came in front, and the -1 came in front. We don't have any logarithms to evaluate because there aren't any integers, and we're done. All right. Last thing, oh my gosh, that was too funny. If you're going to write as a single logarithm, if you're going to condense, here is where you want to use the power property first. Use the power property first. So looking at A, I see that I do have an exponent here, so I can move it up to the exponential spot. Sorry, I shouldn't say exponent right away. I see that there's a number being multiplied in front, so that leaves us with the log base 3 of x minus the log base 3 of 7 squared. Okay, let's compute 7 squared. So we have the log base 3 of x minus the log base 3 of 49. And double check, are the bases the same? If they aren't, we can't use the properties. Oh my golly, my Surface Pro is even telling me to stop. Okay, so since we have subtraction, we can rewrite this as the log base 3 of the first term over the last term. Nothing else we can simplify, so this is our final answer. Yay! Okay, well, let's do another one. First, is there a power property we can use? No. All right, but I do see that we have a plus sign and that the bases are the same. So let's go ahead and set this to be the log base 8 of 48 times 4/3. Couple of different ways you could go about this. You could multiply and reduce, but I'm just going to cross cancel. So 3 becomes a 1, 48 becomes a 16, and we get the log base 8 of 64. Ooh, can we evaluate it? Can we raise 8 to some power and get 64? Sure can. This evaluates to 2. Yay! Excellent. So again, power property use first if you're writing as a single logarithm, last if you're expanding like we saw in example 3. Okay, I fibbed. There's 2 more I want to do, and they're the solving problems. We'll just do this one because it is one of the properties. Okay, so for C, if we look at C, well, maybe we'll see. I don't know. Hang in there. We had a property where it said if we had a log base A of m equal to the log base A of n, we could just set the quantities equal. Let's make that happen here because we're almost there. The only thing I see is that the 2 needs to come up to the exponential spot thanks to the power property. Okay, so then we get the log base 5 of x minus 4 squared equal to the log base 5 of x. Since the bases are, oh my golly, driving me batty, everyone. Since the bases are the same, we can drop the logarithms and focus on making the quantities equal, just like we did with our exponential exponents. X minus 4 squared is going to cause us to FOIL the quantity. We get x squared minus 8x plus 16 is equal to x. With a quadratic, we need to set it equal to 0 in order to solve. So let's subtract the x over x squared minus 9x plus 16 is equal to 0. Now, it'd be real gosh darn nice if it factored, but does it factor? Anything multiply to 16 that add to -9? Nope. So we're going to have to solve through either completing the square, or the quadratic formula. Okay, so you pick one and solve. What I'd like for you to do is to complete C, attempt D, and E, And in class on Monday, we'll go over D and E together. There is homework to be working on that's going to help you evaluate and practice with the properties, but know that we will complete D and E. Well, we won't complete it. That's your job. We will check it when I see you on Monday. Thanks, everybody.